In this tutorial, I'm going to give you an introduction to Redshift in Maya. I'm not going to explain anything in depth, but rather give you the basic tools to start rendering today. This is the scene we're going to work on in this tutorial. As you can see, it's very simple with just a few objects. Let's start off by checking if the Redshift plugin is activated. Go to your plugin manager and make sure that Redshift for Maya is loaded and autoloaded. Now let's create some materials. As you can see, there are already some materials in the scene. This is so that the tutorial doesn't get too repetitive. To create your first material, open the Hypershade window, find the Redshift tab and left click on the Redshift material. Make sure to name your materials properly. This material is gonna simulate white paint, so I'll select everything in my scene that I want to apply this material to. Right click on my material and apply to selection. Let's change the color and reflection roughness for the material. The roughness value determines the glossiness of your material. Set a low roughness value to get a glossy reflection, as you can see in the preview thumbnail. I'll set it to a medium value for this material. For our second material, we're going to use one of Redshift's very handy presets, copper. Apply it to the lampshades using the same method as before. Our third material will be for the custom wallpaper. We're going to use an image file as the diffuse color. In the diffuse color slot, click the checkered box, File, and then the folder button. Select the image texture and open. Adjust the reflection roughness and weight to something you like. For our next material, we'll use a ramp as the diffuse color. Redshift supports many of Maya's nodes. The ramp is one of them. Use the noise values to give the pot material some texture. Apply the material to the flower pot and adjust the reflection settings. The last material is for the cabinet doors. I want it to simulate a pretty matte blue paint that matches the wallpaper. Use the color picker to sample the color from the wallpaper in the viewport. Now let's move on to creating the camera. Redshift supports Maya's default cameras, so create one in the same way as always. Position the camera and frame the image as you like. Activating the resolution gate will help you position the camera properly. Now let's add our lights. You can either create the lights in the Create menu or the Redshift specific menu to the right. Either way will do the same thing. Create a Redshift physical light. As you can see, it creates an area light as the default. You can change the light type in the attribute editor. My first light is going to be a spotlight. I'll try and simulate the sun, so I'll position the light angle down with a wide cone angle. Let's see how that looks using IPR. Make sure that Redshift is selected as the rendering engine. Go to IPR and render using camera 1. As you can see, it's way too dark. Let's crank up the intensity multiplier on the spotlight to get some more light emitted. That's better, but there are still much to do. Let's set the shadow softness to a higher value on the spotlight and see what happens. As you can see, the shadow's edge becomes much softer. At the moment, there are only direct light illuminating the scene. Let's activate global illumination and see what happens when the light bounces around. Open up the render setting, go to GI and select Brute Force and Radiance Point Cloud as your primary and secondary GI engines. The unlit areas are now affected by the spotlight in an indirect way. Let's switch over to bucket rendering and adjust some GI settings to reduce noise. Let's set the num raise to 64 and see what happens. This will affect rendering time. As you can see, the noise is reduced a lot. Now let's illuminate the scene even more without boosting the GI. I'll create another light, but this time keep it as an area light. Scale it to fit the window and render using IPR. As you can see, it's completely black. This is because the light is treated as an object with a visible shape. Uncheck the area mesh visibility so it isn't in the way of the camera. The area light is much more sensitive to the intensity multiplier, so let's set it to a low value. Now it's starting to look pretty good. Let's fill the other window with another area light. Since we want to simulate the sun, we need to adjust the spotlight's color. Set it to a warmer color to get a more realistic result. Let's do a bucket render and compare the results. Now let's get rid of some of that shadow noise. In the spotlight, go to the shadow settings and set the shadow samples to a higher value. As you can see, the noise is reduced. Now I'll do some final adjustments to the lights. Reducing noise is a big part of working with Redshift. Everything is separated into different values, which makes the rendering so fast. Let's reduce the noise on the material this time by setting the reflection samples to a higher value. Some materials don't need this value to be high, so we can save a lot of rendering time if we just adjust the materials that needs it. As you can see, it removed some of the noise from the cabinet. But it's pretty hard to see. Let me give you another example. In this example, the noise reduction is much more obvious. Finally, let's add a lens shader to the camera. Select the camera, go to the Redshift settings and click the checker box on the lens shader input. Go to the Redshift tab and select Photographic Exposure. The Photographic Exposure shader will give you controls that you can find on a real-world camera. By default, the shader will bring light intensities into control, so they don't appear too blown out or too dim. I'm going to bring back some of the contrast using the allowed overexposure and black rush settings. I'll also set the ISO to a higher value. Now it becomes a bit too overexposed, so I'll tweak the settings some more until I have the results I want. Now I've created a new camera and positioned it capturing a close-up of the lamps to show you another lens shader, the bokeh. Add it in the same way as the photographic exposure. I'll uncheck the derive focus distance from camera option so we can manually set it in the bokeh options. Let's see what happens if we render using the defaults. It becomes totally out of focus. Let's figure out the focus distance using Maya's distance tool. Hold V and left click on the camera and then on the object you want to focus on. Adjust the position as you like by adjusting the locator that was created. Now you can just copy the distance value in the attribute editor and paste it in the focus distance on your bokeh shader. Starting to look pretty good, but we have some nasty looking noise that we need to take care of. Open up the render settings and go to Output. Adjust the unified samples, but be careful as this will affect the rendering time. That's all for this tutorial, thanks for watching. Hope this video inspired you to start rendering using Redshift.